15th, right? Good. So 12.5, logarithmic functions. Okay. We already know how they look like. There are two shapes. Here is the first one. We graphed them last time with a base greater than 1. And I'll explain the notation in a moment. Increasing on all its domain. And the other one with base less than 1, decreasing on all its domain. Now let's analyze this before we look at the graphs. We graphed them because we had them last time, but we have a few things to talk about here. I will also graph the exponential function just as a reminder because I'm going to ask you a couple of questions about the exponential function. So this was 2 to the x, and this was 1/2 to the x. So if you look at these two graphs, this graph, the purple graph, I'm not sure whether you see purple. So this is purple. So 2 to the x and 1/2 to the x, which we call the exponential. Can anyone give us the domain of the exponential function? What did we say, the domain? You don't have to even think of anything other than just look at the graph and tell me the domain of 2 to the x.
Infinity to infinity.
Thank you very much.
Or negative.
Very good. So this is domain. Now, can anyone give us the range of this function? Again, from the graph, you can establish the range. We can determine the range, and I'll put it in. Say it again.
Negative infinity.
Look at the graph, the purple graph, and the purple graph. 2 to the x and 1/2 to the x. Careful. 1 is here. So it cannot be 1. 1 is here. 0 to infinity. Good. So then what about the log function? That is the inverse function. And I'll explain the notation in a moment, but I want to establish its domain. So this is the range. Can anyone tell us, once I say that the log function is the inverse of the exponential, we can determine the domain. What is the domain of the log function?
That's the second graph, right?
Yes, it's this one exactly. And this one. Very good. Yes. Yes, we want to find the domain first. But this is the inverse function of the exponential. If the exponential is defined on all real numbers and gives us 0 to infinity, where do I define the inverse function? Okay, one more time. I have negative infinity to infinity, and the answer is 0 to infinity. Where do I apply the inverse function?
0 to infinity.
Right, on 0 to infinity, and it will return.
Negative infinity. 0.
Thank you. We established that, right? A long time ago. Domain. Because they are inverses. Otherwise, this will not be true. But they are inverses of each other. How do I know? First of all, we graph them by reflecting 2 to the x and 1/2 to the x over the line y equals x. So looking at the domain of this function, I will say right away that log is not a friendly function. Why do you think I say that? And I claim that the exponential is friendly. No headache. No headache. It will never give me any problems. But log gives me problems, like the square root, right? The square root is not defined everywhere. The cube root is nice and fine, and right, because it's defined everywhere. But log is that type of function that requires thinking. It's not a friendly function. Look at it. It's defined only on 0 to infinity. So that's one thing that we need to talk about. So as you see from the graph, the domain of this function is from 0 to infinity, and the domain of this function is from 0 to infinity. Okay? Good. Now notation. And now I'm going to put a notation for each. First of all, the inverse function, so it's called logarithmic function. The notation is log base 2 of x. So this is f inverse for the function f of x equals 2 to the x. So the function 2 to the x has an inverse function that is f inverse log base 2 of x. So here's how we write it, how we read it. Log base 2 of x. Log base 2 of x. So I'm coming back here. So the inverse function of 2 to the x is log base 2 of x. Can anyone give us the name of this function, which is the inverse of 1/2 to the x? What do you think? Give it a shot.
Log base 1/2 to the x.
Of x. Correct. Log base 1/2 of x. And those are inverses of each other. The most important concept in this chapter, the most important concept here is, I will write it in plain English first. Any log equation can be, what would you like me to use? Replaced, substituted with, equivalent is equivalent to. What do we like me to write? Okay, I'm going to use replaced, okay, with an exponential equation and vice versa. Any log equation can be replaced with an exponential equation, and any exponential equation can be replaced by a log one. The most important concept here. Now, in mathematical terms, how do I write this? Here's how we write it. Log base b of x equals a number y. Log base b of x equals a number y. This is the double equivalency symbol, which means this equation can be replaced by this, and this equation can be replaced by that, going back and forth. So here's how we write the exponential equation. We start with a base and we go counterclockwise. Base, counterclockwise. B raised to y equals x. B raised to y equals x. From the base, b raised to y equals x.
What happens to the log?
I'm sorry?
What happens to the log?
Any log equation can be replaced by an exponential equation. Any exponential equation can be replaced by a log equation. Very good question. Very good question. I'm just looking for a bottle of water. So now, our next step is, I have to convince you that this is the inverse function, right? I haven't convinced you yet. Okay. So let's look at a couple of bubbles here, or just one pair. Give me an exponential function. Pick an exponential function that you want to work with. Any exponential function.
2x equals 4.
2x equals 4 is not exponential.
2 to the
2 to the x. That's good enough. 2 to the x is an exponential function. Let's pick 3 values of x. You choose. I need to have 0 in there, and you choose a positive and a negative that you want to work with.
2 and -2.
Very good. Let's put 2 and -3. Good. So now I would like anyone to tell me what is the corresponding in this set, the corresponding in this set, and the corresponding in this set when you apply function 2 to the x to 2.
4,
Perfect.
1,
Perfect.
and 8.
2 raised to -3 is?
8.
No. Then what is 2 to the third? If 2 to -3 is 8, then what is 2 to the third?
1/8.
Excellent. Perfect. So now I have to show you that when I go back to this set, I go back with F inverse. Can anyone dictate what should I write? What is the F inverse of 2 to the x?
Which one? For x equals what?
Not yet. I just want to write the function here,
Oh, F inverse will be
right?
Oh, x. 2.
what are you looking for?
The inverse function of 2 to the x. Yes?
Please go back.
Thank you. It's right there in your notes, right? We just wrote it. We just wrote it, right? Okay, perfect. Thank you. So now I have to convince you, which I haven't done yet. I only said to you here, this is the inverse function, but I haven't showed why. So here's what I'm going to do. In order to convince you, and I hope I can, I will apply log base 2 to 4, and I have to show you that the result is? Exactly. I will apply log base 2 of,
1,
and I have to show you that the answer is exactly
0,
perfect. And I have to apply log base 2 to,
1,
and I have to show you that the answer is right. I haven't showed that yet. Good. So let's do that step by step. So log base 2 of 4 is a number y. And this is equivalent to, according to the most important concept in this chapter, tell me what to write. Yes?
2, 4.
Counterclockwise.
2y.
Yes. 2 raised to y equals?
4.
Good. Now let's think. We've solved these equations last time. So I know that the left-hand side is 2 to the y and the right-hand side is?
4.
2
Very good. Two numbers are equal. They have the same base. What should y equal to?
2.
2. So I hope I convinced you that when we apply log base 2 to 4, we recover what number?
Y.
We recover 2. Now I will do the same thing to 1. So now I have log base 2 of 1 is y. I have no clue what that means, but I know that it's equivalent to an exponential equation, which will be 2 to the y equals. And now let's think. What power do we take y 2 to get 1?
1. No, 0.
0 indeed. So I hope I convinced you that now 1 returns 0 when we apply log base 2 to 1. Agreed so far? Any questions? Stop me if you have questions. We're going to practice this in a minute. I just want to show you the last one. So I have to show now that log base 2 of 1 over 8, which is y. I have no clue what that is, but I know how to change it into an exponential equation. And how do I do that?
2 to the y.
Very good. Equals? Very good. Now I know from last time, I know how to solve this type of exponential equations by getting both sides with the same base. 2 to the y equals, and what does 1 over 8, what can 1 over 8 be replaced by?
Choose -3.
2 to negative 3. Very good. So 1 over 8 is the same with 2 to negative 3. Now I know the two numbers are equal. They have the same base. What has to happen for sure?
Y equals negative 3.
Y equals negative 3. And I showed that indeed 1 over 8 through this function goes back where it came from. It means that log base 2 of x is indeed the inverse function of which function? Of which exponential function?
F of x equals 2 to the x.
Excellent. Thank you. Good. Now I would like us to practice what we just looked at. On page 749. Write each as an exponential equation. So let's say we start with number 3. Log base 3 of 1 over 27 is negative 3. They only want us to convert it into an exponential equation. Can anyone convert this into an exponential equation for us?
32 to the negative 3.
Excellent.
Equals 127.
Good. Is this true? Yes, it is. Perfect. Very good. Okay. Problem 11. Log base 7 of the square root of 7 is 1/2. Can anyone convert this log equation into an exponential one?
72 1/2.
Excellent.
Square root of 7.
Yes. Is that true? We learned this in chapter 10. The square root of 7 is the same with 7 raised to 1/2. Agreed? Good. Okay. Before we continue, I would like to mention the fact that there are two special logs. Two very special logs. And they correspond to two special exponential functions as well. Here is one. I don't see a base.
Is it just 1?
It's base 10. Base 1 cannot have. We cannot have 0, 1, or negative numbers. Right. So this is base 10. What will be its inverse function? Its inverse is
10 to the x.
wonderful. This is called, the 10 to the x is called common exponential function. How do you think this is called?
Common log.
Very good. Common log function. And I'll show you something in a minute. Here's one more. lnx. The base is e. Can anyone give us its inverse?
ln. Is that ln?
Yes, ln. I'll tell you what it is in a minute.
E to the x.
Very good. This is called natural exponential function. How do you think this is called?
Natural log.
Exactly. Good, so let's look at the graphing calculator for one moment, if you allow me, and I'll come back. So as you see right here, there are two keys. One with log, which means base 10, and you can see it in blue or in yellow. You have 10 to the x. These two functions are inverses of each other. So second and log will give us 10 to the x. And just log x is the inverse function. So 10 to the x and log x. Now here's the other key that I was just talking about, right here. So natural log x, or the inverse function, which is, I don't know what this is, because I didn't put any x, but maybe there is an x in there, I don't know. And then second e to the x, okay? Interesting. I just put a function with no variable, no value for x, and it gave me a number. Anyway, so e to the x is the exponential function, the natural exponential function. Log x is natural log function. Common log and 10 to the x are on the same, of course, on the same key because they're inverses of each other, like e to the x and ln. Any questions? Any questions so far? So now we'll continue with examples. I needed this information so we can continue with other example with ln and log. So here's one. Natural log 5 equals x. I want to write the exponential equation that is equivalent to this. Careful, what is the base of ln? E. So E x equals, excellent. Here's another one. Log 10 is 1. This is equivalent to ten, because that's the base here. 10 raised to 1 equals 10. Now they want us to write each as a log equation. So let's start with, let's say, 25. Same page, 749. Because I like to write the property, the left-hand side I have log and the right-hand side I have exponential. When I'm given the exponential, I write it on the right-hand side and I create the left-hand side. When I'm given the log, I go this way. When I'm given the exponential, I'm going this way, so I don't mess it up. Now, of course, if you have a different method, I accept it. So in this problem, in 25, I am given 4 raised to negative 2 equals 1 over 16. And I want to go back. And I know the following. I know that I have to have a log. I know that I have to have a base. I have to apply it to a number. And I do get a number. Of course, these are not the same. So don't get confused at the fact that I wrote the same symbol. I put the same symbol in all 3 spots. They're not the same. So I always start with the base. What is the base? 4. What do I raise it to? -2. Good. And what will I get?
16.
I recommend this method and you will never mess it up. Okay, next problem. Let's say 28. 4 raised to 1/3 equals the cube root of 4. And I just said it, I'm going to write it to the right, and I didn't. Sorry about that. So I know that I have to have a log, some base, some power here, and some number inside.
The base is 4.
The base is 4. What do I have here?
1 over 3.
1 over 3. And what do I have here?
Cube root 4.
That's it. Do we need more examples of going back and forth from log equation to exponential and from exponential to log?
One more.
Okay, of each or just the last one?
Yeah, go ahead.
The last one? Okay, very good. Let's look at 10 to the 4th equals 10,000. And this is problem 20. Yes, 20, yes. I know I have to have a log. Right, so I don't have to write anything. Because when base is 10, by convention, we don't write it. So then what is the answer here?
4.
And what number do I apply it to?
1000.
Very good. Now, we want to solve a few logarithmic equations. Here's a note. What did I say when we started today about log function that I could not say about exponential?
It's still like it's not an easy one.
Right, because I have to worry about it. Yes. So here's an example. 48. Log base 2 of x is 3. Remember, log has to be applied to positive numbers. So on the side somewhere I write, hey, make sure that x is positive, because log has to be applied to positive numbers, not even 0. And now I can change it into an exponential equation. How do I change this into an exponential equation so I can get x?
Is x the base? Three rows of
There's the
base.
base.
So what do I have to write?
Absolute value. Search for the third
No, no.
results.
No. So first, 2 to the
Third.
equals,
X.
good. 2 to the third equals x. So x equals,
8.
good. Is it positive?
Yes.
Acceptable. Let's say problem 59. Log base 3/4 of x is 3. Again, this is a log equation. I have to write a little note to myself. Make sure that what you get is positive. And now I can change it into an exponential equation. How do I change this into an exponential equation? What do I have to write?
3/4 to the power of 3 equals x.
So therefore x equals, the top will be,
9.
careful, one more time,
27.
good. And the bottom will be, good. Is this a number greater than 0?
Yes.
Good, acceptable. Any questions?
Really, is there a point where it would be less than 0?
Yes.
Then what do you do? What are we doing?
I will say no solutions.
Oh.
Absolutely, bless you. I will say no solutions. So remember, we solved radical equations, and sometimes the equation had solutions, sometimes it did not. We went back to replace, we substituted, we checked, it didn't work. Okay, so that can happen. Okay, let's look at 51, where x now is in a different spot. So here I cannot write a restriction on x. Only if log is applied to x, then x has to be positive. But this log is not applied to x here, so there are no restrictions here.
There's no solutions because x is -3.
So let's try. But this is not in log. When x is in log x, I have to write greater than 0. Log x, I have to write greater than 0. But here is not, log is not applied to x. So there are no restrictions here. Whatever I get should be okay. So what do I have? 2 raised to x equals 1 over 8. So then x must be,
-3.
right. But in this problem, there are no restrictions for x because x is not inside log. Okay. Let's look at, say it again.
Sounds good with like the last one just did.
Okay. Good. I love when I hear that. Log base x of 1 over 7 equals 1/2. Now there are restrictions. What can x be? Remember, x is the base now. So here, let's see the difference among these three. Here x is inside log. I have to state this. Here x is outside log. I don't have to touch it. It can be anything. But now X is the base. And now let's think, what can we have as the base? Exactly, not 0, not 1, not negative. So I have to make sure that X is either between 0 and 1 or between 1 and infinity. If I get 1, if I get 0, if I get a negative number, I will have to exclude it. Disregard it, whatever you want to say. So then I can change this into an exponential equation. How do I change that?
X.
To the good equals 1 over 7. Good. So I hope I didn't copy it incorrectly. Let me see. What was that? For 67? No, I copied it correctly. Good. So then, what is the next step here? I have to solve this equation. What is it?
Oh,
Is there any other way of writing this equation?
you could
So what is x to 1/2? What is another way of...
square root of X.
Excellent.
Square root.
Good. So now maybe it's easier to remember how to solve this. Chapter 10. What do we have to do in order to solve this equation? Wonderful. So then the left-hand side is
X.
good, and the right-hand side is
1/49.
good. Is 1/49 greater than 1 or between 0 and 1?
Yes.
Acceptable then. Very good. Any questions? Any questions? Okay. The last section is just the same thing, which was more examples. So 12.7. More of the log. Okay. So they want us to find the exact value. So for example, problem 15 on page 762. In problem 15, we're asked to find, without a calculator, log 100. And I'll say, have no idea. But I know how I'll say it's y, whatever it is. Well, I'll figure it out in a moment. But I can change this into an exponential equation that will help me solve in a blink.
10 to y goes on. Yeah.
So what should y be?
10. No, 2.
2, indeed. 2, indeed. Okay. What about natural log, number 20. Natural log of e to the 4th. I have no idea. But I know how to change it into an exponential equation. And then I will figure out what y is.
E to y.
Excellent. E to y equals,
4.
careful, equals, say it again.
It's not 4.
No, I don't have 4. What do I have?
10.
No. So what is this? What is natural log applied to? So how much is it? Is it 4? No, it's not 4. What is it? What is this? No one wants to read this number.
E to the 4.
Right! Exactly. That's what we applied natural log to, right? A natural log. I apply natural log to this to get y. So e raised to y equals this number, correct? Perfect. So then what is y?
Y is 4.
Very good. Okay. Let's look at 28, which is log of 0.001. I have no idea what that is, but I know how to change it into an exponential equation, and I will be able to figure it out.
10 to the y.
Very good. Excellent. Good. So now I can say, oh, how can I present the other side with base 10? I can. So the other side is base 10 raised to which power? It cannot be a positive power.
1 over.
Right. 1 over 1,000. But what is, how do I write that?
Over 3.
-3. So then how much is y?
-3.
Very good. Okay, let's solve other equations now. This was not an equation, we were just asked to evaluate. So let's start with 39. And this is the end of chapter 12. 39. Natural log of 3x minus 4, they say equals 2.3. After this, I'd like to pick a couple of examples for you to work on for a minute. So now, I remember that when I look at when I have to solve a logarithmic equation, I have to state a domain or a condition. This quantity must be, log is applied to it, so this quantity must be, no. So previously when we had log applied to a quantity, we said that that quantity has to be greater than 0, otherwise we cannot apply log to it. What is the quantity that we apply log to this time? What has to happen to 3x minus 4 for the log to exist? Excellent. So then x must be greater than 4/3. 4/3. So if my solution, whatever I get, is not a number greater than 4/3, I'll say sorry, no solutions. So let's start. This is a log equation. It can be changed into an exponential one. How?
E to 2.
Right. E to 2.3 equals,
E to 3x minus 4.
careful, E to 2.3 equals 3x minus 4. E raised to 2.3, 2.3 equals 3x minus 4. Do we agree with this? Yes? Jason, agreed? Everyone? Right? Okay, one more time. One more time. E raised to this number equals this.
Oh, I see.
Is that clear?
Yeah.
E raised to this equals this, whatever it is. Okay, so now I have to solve for x. How do I solve this for x? Don't be bothered by e to 2.3. It's just a number. So how do I solve for x? Now this is linear. This was a logarithmic now, but now this is linear. How do I solve a linear equation? Add 4, of course. E to 2.3 plus 4 equals 3x. And finally, x is? Wonderful. I have to plug this in a calculator and make sure that it's definitely greater than, careful, greater than 4/3. If it's not greater than 4/3, I'll say, sorry, this equation has no solutions. So let's do that. So careful how you put it in. You have to have parentheses on the left and on the right at the top, right? So e raised to, it's right here, e raised to 2.3. Close the parenthesis. Please close the parenthesis. Plus 4. And divided by 3. It's more than 4, and 4/3 is a little bit more than 1. So would you accept the solution or not? Yes, we accept the solution. Be careful. This is a difficult function in the sense that the domain is not all real numbers, exactly like with the square root when we solve the equations. So I'll say greater than 4/3. Okay. Okay, let's look at other problems.
Do you know why the
Yes?
LN is backwards?
Yes. It comes from German.
Oh, so they say
It should have been NL, right, natural log, but it's, yes, they do. They put the noun Then yes. Yeah, they put the noun first and the adjective after. Yeah. Okay, let's look at 46. Oh, I said 44 and okay, sorry. And natural log x equals negative 3.7, and then I will let you work on 46. Log of 3x minus 2 equals negative 0.8. So I want two answers from you. Remember, you have to state two restrictions, one for each. And then I'll put in my attendance.